As we approach AGI, do you think it's going to be a slow takeoff or a fast one? Sam Altman shares his view on the matter. In the meantime, Google drops Genie, which means that there's yet another AI superlab pursuing foundation world models. Are you noticing how the time between big breakthroughs in the AI space is getting smaller and smaller? The rate at which we're seeing these events happen is getting faster. Now, some say the singularity will be here when the rate of AI progress is too fast to follow. How far away do you think we are? All right, so let's get started. So Google DeepMind drops another really exciting breakthrough in AI. So this is Tim Rock T, I guess that's his handle, and he's saying he's excited to reveal what Google DeepMind open-endedness team has been up to. They introduce Genie. Genie is the thing that we'll be talking about today, a foundation world model trained exclusively from internet videos that can generate an endless variety of action controllable 2D worlds given image prompts. Rather than adding inductive biases, we focus on scale. We use a dataset of over 200,000 hours of videos from 2D platformers and train an 11 billion parameter world model. In an unsupervised way, Genie learns diverse latent actions that control characters in a consistent manner. So if some of this does not make sense, we'll kind of unpack all of this in the actual paper. And they're saying our model can convert any image into a playable 2D world. Genie can bring to life human design creations such as sketches. So I guess here's some sketches from young players, young world creators. And so it turns their sketches into worlds. And Genie's learned latent action space is not just diverse and consistent, but also interpretable. After a few turns, humans generally figure out a mapping to semantically meaningful actions, like going left, right, jumping, etc. And you say, admittedly, OpenAI's Sora is really impressive and visually stunning. But as Yann LeCun says, he's the AI boss at Meta/Facebook, a world model needs actions. Genie is an action controllable world model, but trained fully unsupervised from videos. So here's Yann LeCun, and so he's saying lots of confusion about what a world model is. Here's his definition. So let's try to unpack this a little bit. This, I think, is really interesting to dive deep into. Dr. Jim Fan has talked about it. There does seem to be some different explanations for what it is. So he's saying, given this, so here's the things that we have, an observation. So let's say you're playing a video game and you approach this door that's like seemingly important. It's very ornate. And then you have a previous estimate of the state of the world. So this is your understanding of what led up to this, like your memory of what happened. So for example, let's say in the previous room, some non-planar character NPC told you, oh, once you passed through the door, only danger ahead, there's no looking back, something like that. And then the action proposal. So this is the next move you're considering, like going through the door. And then you have your latent variable proposal. And so we're going to be seeing these words a lot, like latent variable, latent action space, etc. So I think a good way of thinking about what latent is, it's not observable. We can't really see it, but we can kind of guess at what it is, or we have some idea of what it is. So an example in statistics, if you know someone's zip code, for example, so the zip code is an observable thing. You can see what it is, what zip code a person lives in. A latent variable might be their socioeconomic standing, right? Are they in the middle class? Are they in the upper crust? You can't really look at somebody and like there's no like stamp on their shoulder saying, I'm part of the 1% or whatever, right? But there are other observable things that can lead you to make that deduction. So in humans, maybe thinking of it as an intuition might be a good way of thinking about it. So what is your sort of intuition about what's behind that door, right? Somebody said it's dangerous, right? The door is big, it's ornate. They said there's no going back. Well, you might guess, well, there's probably a boss on the other side of it, right? You don't know this to be the case, but based on where you are, your observation, based on all the stuff that led up to where you are, and based on kind of what you're thinking about doing, which is walking through that door, what do you think is going to happen? You don't know what's going to happen, but what do you guess is going to happen? Well, there's going to be a big bad boss there, and you can't escape until you beat him or die. So a world model computes in this situation the representation. So this is like taking into account everything you're seeing around yourself and encoding it into kind of a mental map, some internal representation of the game world, right? If you're playing Diablo, you come to that door, an experience-based game. It seems like you're getting to the end of a dungeon or whatever, right? Like all those things, that information is what you've picked up by looking around. Then prediction. So based on where you are, kind of your mental map of the world, the moves that you're considering, and your guesses at what you can't see, like what's behind the door. This is the prediction that you're making of what happens after you make that action. So what happens when you go through that door? So this is the encoder. So this is like your brain thinking about the situation, like a neural net. This hidden state predicted as your brain kind of thinking about all the information that you have available to you to figure out kind of what happens next. And the latent variable is that sort of unknown information. So for example, if I walk through the door, there will be a boss there that will fight and I have to be ready for it. That's the thing that you're guessing that will happen if you take that action. So how are they able to create this from videos and, fully unsupervised? So they use a temporally aware video tokenizer. So something that is able to kind of break down these videos into tokens. So you can think of those as words or letters, sort of units of video, and temporally aware, meaning it knows kind of the time of that clip, of that shot, of that frame. And then this next part basically says that there's a process that's going on that figures out kind of like what action was taken between two frames. So if you see in one frame, the character standing on the ground, and in the next, he's, up in the air, like what action happened between those two frames? Well, he probably jumped, in this case, let's say jumped forward. And the mask get dynamics model. So this is basically predicting what happens next. So if he was standing here and then he jumped into this chasm, right? He's here. This is the current moment. Like, can you predict what happens next? Well, he's probably going to fly down, continue his trajectory, but fall into the chasm. Next, they hit it with lots of compute and data. So basically scale, right? More data, more high quality video, and lots of computer chips. And this is where it gets extra interesting, because basically more and more companies and people are talking about this idea of foundational world models. So basically, if you can imagine an agent, an AI, that is able to learn in any sort of reality, whether that's something like this, where you're watching a claw grip something, or jumping platform to platform, or whatever, basically playing any video game, controlling any robot looking thing, whatever. If they're able to just generalize and learn across all realities, then it becomes pretty simple then to take them out and have them run around in the real world, for example. So if we're able to simulate physics in a simulation, and the robot, this AI agent, can get really good at controlling the robot there and across all similar types of realities, he's going to be good in the real world. And so they're saying when we train Genie on robotics data, so this is the RT1, Google DeepMind's their robot that's kind of using a combination of a language model, a vision model, and kind of an action model. So it's kind of a language, vision, action model. So they're saying when we train on that robotics data without actions and demonstrate that we can learn an action controllable simulator there too, we think this is a promising step towards general world models for AGI. Boy, we're seeing that word more and more nowadays, aren't we? So here's Dr. Jim Fan. So he's saying, Tim, that's this person that we just read the tweet by, he's one of the most imaginative researchers I know, and Genie is one of his most imaginative works. Unlike Sora, Genie is actually a proper action-driven world model with inferred actions. 2024 will also be the year of the foundation world models. All right, so let's dive in. Genie, generative interactive environments. So Genie is capable of converting a variety of different prompts, so they can use real-world photos, sketches, text to image. You can just write out what you want to see. And they're able to create interactive, playable environments that can be easily created, stepped into, and explored. This is made possible via a latent action interface. We kind of talked a little bit about that earlier. So they're saying Genie was trained in an unsupervised manner from unlabeled internet videos. So unsupervised means we weren't training it towards a specific outcome that we were looking for, or a specific correct answer that we were looking for. We said, just look at all this data and figure out what you can. So it's more of an open-ended learning process. Unlabeled internet videos means that we weren't telling it what buttons are being pushed for the actions that are taking place on screen. So if you had labeled internet data, every time the character would jump, you would also make an annotation there saying, okay, the player pressed B. And so the model would understand, okay, when B is pressed, the character jumps and moves upwards. Here was unlabeled, meaning that it had to figure everything out by itself. So as it watched these videos, it figured out, okay, it looks like when they're pressing A or B or whatever they're pressing, this is the result that appears. So it's able to figure out what's happening in the video and also kind of correlate that to the buttons that are being pressed for those things to happen. And so it's able to generate an endless variety of action controllable virtual worlds with text, synthetic images, photographs, or even sketches. At 11 billion parameters, Genie can be considered a foundation world model. So next, it mentions the video tokenizer, latent action model, training without labels. So we've covered some of this already. So those are some of the things that Tim covered in the tweets earlier. And then they kind of say what the point is here. So further, the resulting learned latent action space. So that's sort of kind of intuition about what's going to happen, what's going to come next, its ability to explain and predict what's happening. It's going to help train agents to imitate behaviors from like new videos that they haven't seen before, opening the path for training generalist agents of the future. And again, NVIDIA is also taking some big steps in this direction, along with other companies as well. So it seems like a lot of the big super labs are converging on this idea of kind of a foundational model, kind of like one model to rule them all, if you will. The last few years have seen an emergence of generative AI, where models are able to create new and creative content, driven by breakthroughs in architecture, such as transformers. So what they're doing there is they're taking their hand, they're kind of patting themselves on the back, because Google is, of course, the people behind the transformers, and as well as advances in hardware and a recent focus on scaling models and data sets. Now these models, we can create coherent text, various images, and it looks like the next frontier is video generation, but it's looking very good with Sora and other things like that. But they're saying still there remains a gulf between the level of interactions and engagement of, let's say, video generative models and language tools such as ChatGPT, this is kind of a big deal. This might be the biggest deal, because if you're able to create something that's able to produce video and text and data, and it's able to take in video and text and data, and it's able to interact with it, like, for example, using a mouse to click on things. Because, I mean, if you think about a game and running around and jumping up and down, that's not too different from, using a computer to surf the web or type in Excel functions or whatnot. They're the same sort of action space. Clicking buttons, moving the mouse based on what's happening in real time on screen. And they're saying, what if, given a large corpus of videos from the internet, we could not only train models capable of generating images or videos, but entire interactive experiences? And so they propose this generative interactive environments. So we've covered most of this already. They're noting here that this architecture of Genie, it scales gracefully with additional computational resources. And to demonstrate the generality of the approach, they also train a separate model on the robot videos from the RT1 data set. So this is showing that robots watching videos can learn to, be better robots, do things more effectively. So here they talk about the latent action model. So that idea of kind of intuitively guessing out what's going to happen, or, using all the data, all the memories that you have to kind of figure out what's happening. The reason why this is exciting is because generally to teach AIs to do something, you had to have, like, let's say, videos plus action labels, writing out what buttons are being pressed that correspond to the character jumping or moving around. They're saying this could be costly to obtain. That makes sense. You would have to have, a human being sit there and write it out. Nowadays, we're seeing some of that being done with AI as well, annotation, like AI doing annotations on videos, etc. By the way, some big news, I think, from OpenAI in that particular space that I think we're going to cover in a different video. But the point here is the AI learns latent actions in a fully unsupervised manner. So this is yet another sort of stumbling block or brick wall that we thought we might hit with training these models that seems like it's not going to be a problem. It's just clear skies ahead. Here they mentioned that they have to limit how many actions, possible latent actions, that the model can have. So basically, instead of having like a million things you could do, there's just a few. I'll link this paper down below because it goes quite deep into various aspects of how they're making a lot of this stuff work. But the point is, in the end, you give it a prompt like this. So this is an image of Indiana Jones standing on this sort of platformer. So you kind of sketch out what that looks like, and it generates a game where you can run around, jump, etc. Same thing for all of these other ones. You can use real world photos, hand-drawn sketch, etc. And they note here that they're seeing clear character movement in these games. Some of the images, they're visually distinct for like one frame from the other. So it looks like it does have, I mean, if you've seen those old school AI videos where everything kind of morphs over time, and you can see it here. He's standing on what looks like a yellow phone or something like that. And then in this picture, I mean, it looks like this object kind of changes, but the point is they're seeing that this character movement remains very, very clear. And this is interesting. So here they're learning to simulate deformable objects. So this is like a bag of chips. That's a bag of chips it's grabbing. And of course, that's got to be a very hard thing to do, since as you're grabbing it, it kind of deforms, it squeezes. And so they're saying Genie is capable of learning the physical properties of objects, such as a bag of chips. It also learned to emulate parallax, so that idea of the background moving at a different rate than the front, commonly seen in these platform games. I mean, it almost kind of makes them look 3D a little bit. And notice here they're saying it's an emergent capability of the model, its ability to understand 3D scenes and emulate parallax. So here's an example of parallax with the foreground, the background. There's like multiple layers that move at different times, at different speeds. So you kind of get this 3D effect, even though everything's 2D. And they're saying this was an emergent ability, meaning that they weren't necessarily training for it. This is something that it learned to do implicitly without being necessarily told to. So here it's learning down, up, left from these images. And despite training without action labels, the same actions are consistent across varied prompt frames and have semantic meaning, down, up, and left. And here is the big reveal: training agents. So agents, if you've been following this channel, we talk about it quite a bit. This is kind of where everything is heading. This is what a lot of people are researching towards, both here in the States with the big tech companies, as well as China. China is releasing a lot of different papers around agents and architecture and benchmarking them, etc. And they're saying that Genie could one day be used as a foundation world model for training generalist agents. So the model can already generate very different trajectories in unseen environments given starting frames. So you give it the first frame and it can kind of like make up what happens from there and even create a lot of different scenarios. They're also investigating if latent actions learned from internet videos can be used for imitating behavior from unseen videos. And here they're comparing sort of what the Genie model will do against the likelihood of an expert taking kind of the same actions. Expert in this case, I think, means just a kid that can play the game. And so basically they set up this procedurally generated 2D platformer that randomly creates these environments. And so as kind of a benchmark, so they're setting up an upper bound is that expert, so somebody that's good at the game. And the lower bound is just a random agent. So it like randomly mashes buttons, right? So it's like that's the worst you could do. And somebody that knows how to play the game, the expert, that's, let's say the best you can do. And so this model achieves the same score, basically, after being given as few as 200 examples to adapt. So after watching the experts move around, navigate for 200 examples, but never having seen coin run before, so it hasn't been trained on that game, it becomes as good as the expert. This is important because what this means is, let's say you have a person that's been playing video games for a long time. They put in their 10,000 hours into it, and then they pick up a new game that they haven't ever seen before. Maybe they watch somebody on YouTube, a video of how to play that game, just a little bit, just to pick up some tricks and stuff like that. And all of a sudden, they're really, really good at the game, even though they don't have a lot of time put into the game. That's what humans are capable of. That's kind of like this idea of a general intelligence, of being able to transfer knowledge from one game to another, even though they could be very different. This does that as well. Those latent actions that it learned, they're consistent and meaningful for transfer. They transfer between games. So here they're giving some examples of what it can do. So for example, this is the prompt. So this is somebody sketched a little character on a brick little platform, right? And then the game plays it out. Genie plays it out. So it looks like it's standing there. It moves to the right. Then it jumps, and then it lands on this platform. And all of that was generated from this just sort of example, this prompt. And they have many, many more that kind of demonstrate that. And one thing that we're going to be seeing more and more of, so this already exists, for example. So this is an AI-powered gaming monitor that helps you cheat at League of Legends. So I don't think this has been released yet, but basically it sounds like what it's doing, so it's paying attention to the screen, specifically to the minimap. And so at any point, it knows kind of where the enemies are, at least when they're visible on the minimap. And it's able to kind of project where that is. So if they're hiding behind a bush, it'll kind of put a little marker there so you know where they are. So even though you might not be able to see them, if there is some information available on the mini map that kind of placed them in that location, the monitor will show this as an overlay on top of the game telling you, hey, there's somebody hiding in those bushes. Is that cheating? Yeah, I mean, I'm pretty sure that certainly qualifies as cheating. It's as they say here, I don't know enough about League of Legends to say whether this officially breaks the rules. But yeah, I feel like this would be frowned upon. I feel like that's kind of the plot behind a lot of these movies where like animals play sports, right? Because it starts out, well, is there a rule against a dog playing basketball? And it's like, nowhere does it say that a dog can't play basketball, right? So therefore it must not be against the rules. The interesting thing here is like, I'm sure there's no rule that says, don't use artificially intelligent neural nets to pay superhuman attention to the minimap and then kind of point out to you where the enemies are hiding. But I still think people will not be allowed to use this for, competitive, professional, whatever you want to call that, for those tournaments. But unless you're playing live and in person with other people, I don't know how you would be able to tell. Because unlike many other cheats that are used in games, this doesn't actually interact with the game itself in any way. There's no software, there's no hooks, there's no memory injections or anything like that. It's just looking at the pixels of the screen. I think we're going to see a lot more things like this, not just with monitors, but just across everything. As AI is getting more intelligent, you're going to have more and more just completely undetectable ways to gain an advantage at a lot of these games. In other news, there's a new interview with Sam Altman. So he's talking to Intel, and they're asking more about a $1 trillion sort of investment into chips. So he's kind of highlighting that it's not sort of like how much cash he expects to be given to make these chips, but the whole infrastructure or stack around that, all the investments that are going to be needed for that. And that's, of course, not over 1 year. That's over a range of time and across the entire world. That's how much he expects will be needed to get the world kind of ready to receive all of the benefits and all the services that AI can provide.
7 trillion. What's this all about anyway? Look, as I'm sure you all know, you shouldn't believe everything you read in the press. The kernel of truth is that we do think that investing a lot of money in AI compute, energy, data centers is going to be important to deliver the amount of services people want and the tools that we all are going to really, I think, get a huge amount of value out of to help create better futures. But it's across a lot of stuff. It's not, this is like a worldwide investment to help many, many different efforts, many different people, and not just chips, of course, but sort of the whole infrastructure stack around it. I think this is going to be one of the greatest tools humans have yet invented. If you think about what we can do with more intelligence available to us, more abundant intelligence, cheaper prices, things that humans on their own are not capable of, we will all be able to invent new things for each other that astonish us. That's how the future gets better. Part of our strategy, what we call iterative deployment, is that we want to put these things out into the world early so that people can adapt and think and provide input, and that we can be ready for the magnitude of change that will come over time.
So he's kind of saying, we're about $7 trillion worth of investments away from having that globally available to us, which certainly that makes a lot more sense. That definitely kind of puts it into perspective. So that's all for AI news for today, because we have quite a few things coming up that's probably as big as Genie, potentially even bigger. There's some chatter about Elon Musk potentially buying Reddit. He bought Twitter for $44 billion. Reddit is looking to IPO at about $5 billion. So chump change. I'm adding a new segment after this, just testing stuff out, seeing how it works. I think some of you might enjoy it. If not, I will see you tomorrow. Same AI time, same AI channel. So I wanted to start answering some of the comments, or highlighting some of the comments that all of you have been making. I really appreciate each and every single one of you that goes and leaves a comment, from the kindest of you to the meanest of trolls. I appreciate it. I think the worst response is if no one cares, if no one watches it, no one comments. That means I'm not connecting in any way, good or bad. So people are talking about Comfy UI. So Comfy UI is for stable diffusion. That's probably the thing that I'm going to dive into next. That's what a lot of people are suggesting. Yeah, the subtitles always say Chad GPT for some reason, which is funny. Larry Niven, love Larry Niven, Ringworld, the Beowulf series, the Protector series. Definitely one of my favorite sci-fi writers. It's hard to say who's number one, but he's got to be maybe my top 5, my top 10 for sure. The Witch on a Broom is Kiki from Studio Ghibli's Kiki's Delivery Service. So a lot of people were very ashamed of me not knowing that. In my defense, I know Totoro. So I own this movie. If you've ever seen it, My Neighbor Totoro. And so they did My Neighbor Totoro, Kiki's Delivery Service, Spirited Away. They have a few that are like big and well known. Looks like they're still producing them. So yes, here's another one. Yes, I hang my head in shame. It did look familiar. I just didn't want to say anything because I wasn't sure. I noticed the globe in the background, totally ignored drawing Africa. So they're talking about the globe right here. So as it zooms out, so first of all, I wouldn't be shocked if it just completely made up random land masses to put on it. But so I think the person's saying that this would be the US, right? Kind of. And this is South America, Brazil over here. So we're kind of looking at like this area right here. But I'm actually not sure if that's the case, because this could be Africa. I know it's distorted. And then this thing is Madagascar. I know it's like much bigger than it's supposed to be. Then this is Australia over here. And then these little land masses are, like Indonesia, Malaysia, Philippines, like over there, right? Because Australia, Papua New Guinea, New Zealand, and like Southeast Asia over here, then this would be Africa, Madagascar, and China up here. But I totally get why, like in this frame, I would totally see like this is US, South America, and then it went right to Australia, skipping Africa. But this looks like the Bering Strait right there, Australia, Africa. So this might be accurate, although distorted. I don't know. Maybe I'm missing something. The newspaper is upside down, I think. That's definitely off. Yeah, that restoration, we went deeper into who did that restoration, a different video. I just kind of glossed over it in this one. But yeah, that's, I think, the worst art restoration in history, as far as I can tell. Some people are saying, don't use the highlight text scroll thing in the beginning. There's this thing that people do, some other unscrupulous channels, what they do is when the Tesla robot, the Gen 2 was launched, the video was launched, I used a clip of that in my video. And a lot of people did, right? Because it was kind of big news. And some subdivision of Univision claimed copyright on like a lot of people's videos, basically stealing their money. So like Farzad here, made a video about it, used a clip from the Optimus, right? And I guess Univision was like, oh, we owned that video, right? Because see, Tesla presented this Nuevo robot Optimus, right? And like, we uploaded first. So basically they just stole the money from this person because they lied. They said, we own the copyright to that video. They didn't. That was Tesla's video. Elon Musk even like responded to it. But the point is, sometimes that's something that people do. And I've had it happen to other videos that were, again, random channels claim copyright on videos that they're not their own. So if I'm using, for example, Sora, that has happened with Sora before. And so if I put some overlays over it, that helps not trigger that. It seems to work a little bit. So that's why I kind of add some of my own stuff to it to kind of prevent people from doing that. But I'll see if I can reduce how much of that is happening. Just as I'm recording this, AI Explained, another YouTube channel, which I'm a big fan of, great content on there. I believe his name is Philip. That's who runs the channel, if I understand correctly. And he's interviewed some incredible people in the space. So he just drops the same subject that this video is going to be about. So I better hurry up and post this. And he's saying the entire industry will not be shocked by this new release. To which I say, we shall see, Philip. We shall see. Anyways, my name is Wes Roth, and thank you for watching.